So I want you to picture this. It's midnight in London, right? June 1908.
A nice, warm summer night.
Exactly. And there's this woman sitting in her garden, and she's reading the small print of a newspaper. But here's the thing. There are no gas lamps on. There are no candles. She is literally reading by the light of a sky that has just, well, it simply refused to go dark.
Which is just wild to think about.
It really is. And what she doesn't know, what nobody knew, is that the light eliciting her to read is actually this distant symptom of an explosion 4,000 miles away. An explosion with the force of 1,000 atomic bombs.
1,000, yeah. And it's the ultimate disconnect between cause and effect, you know.
Absolutely. And so, welcome to this deep dive. I'm so glad you're here with us. We are taking your stack of sources, the historical accounts, the raw scientific data, those long-forgotten eyewitness logs, to really unpack the largest cosmic impact in recorded human history.
And it is a fascinating one to unpack.
Right. Because what happened in 1908 announced itself to half the planet as this beautiful, almost magical light show, and then it waited 19 years for anyone to actually go and investigate it.
19 years. I mean, the sheer scale of that symptom, the light show you mentioned, it was baffling to people.
Yeah.
All across the top of the northern hemisphere that week, people experienced this enchanted bewilderment.
Because the nights were they were too bright to be night.
Exactly. People in England were out on village greens playing cricket at midnight.
Cricket at midnight.
Yeah, at midnight. And we have records from captains out on the North Sea writing in their official logs that at, 1 o'clock in the morning, the sky was bright enough to steer their ships by.
Oh, wow.
They described it as being blanketed in this soft silver rose glow that just absolutely refused to fade.
Okay, let's unpack this, because I was looking at the meteorological records and the sources, and it wasn't just light, right? There was a physical atmospheric disruption too, but scientists at the time completely missed the connection.
They were completely at a loss. I mean, in England, there were these atmospheric pressure measuring devices called barographs, and they were quietly recording this massive pressure anomaly.
It wasn't like a windstorm or something.
No. We need to understand what kind of wave we are talking about here. This wasn't a gust of wind. This was an acoustic gravity wave.
An acoustic gravity wave. Okay, what exactly does that mean?
Well, when an explosion of that incomprehensible magnitude displaces the atmosphere, it creates a wave that moves through the fluid of the air, and it's governed by gravity and buoyancy. The wave was so profound that it rippled outward and actually circled the entire planet.
The whole planet.
More than once, actually. It went around more than once. But in 1908, not a single astronomer or scientist connected this eerie silver rose sky or those subtle barograph dips to a localized event.
It's it's like standing at the edge of a vast, calm pond,
Yeah.
right? And seeing these incredibly faint, silent ripples gently washing over your feet.
Yeah, that's a great way to put it.
And you are completely charmed by the ripples, but you're completely unaware that out in the dead center of the pond, this massive boulder was just dropped from the heavens.
Dropped from space.
Right.
Yeah.
And to understand that boulder, we have to leave the quiet gardens of London and travel 4,000 miles to the east, straight into the heart of the Siberian taiga. We need to rewind the clock to the morning before those bright nights even began.
So we're looking at the exact date of the morning of June 30, 1908. Or June 17th, if you're going by the old Julian calendar that Russia was still using at the time.
Right, they hadn't switched over yet.
Exactly. And the time is somewhere between 7:45 and 17 a.m. local time. The location is the airspace over the Tunguska River, which is also called the Stony Tunguska, right in central Siberia.
And while the rest of the world would eventually see those pretty lights, the reality in this airspace was just apocalyptic.
Oh, completely apocalyptic.
I was reading the eyewitness account, a settler named Semenov, in the sources. And the physics of what he experienced it totally broke my brain.
Mm-hmm. It's a harrowing account.
Really is. So he was stationed at the Vannevar trading post, which is about 40 miles south of the epicenter. And he reported sitting on his porch when the sky to the north literally split in two and filled with fire.
Split in two.
Yeah. But here is the detail that just stopped me in my tracks. He said the radiant heat was so intense that he panicked, believing his own shirt had caught on fire. And then, only then, he was thrown from his chair by the blast.
Yeah.
That implies the heat hit him well before the concussive wave, right?
It did. And that sequence of events, well, it's a brutal lesson in physics. Radiant heat from a multi-megaton blast travels at the speed of light.
Which is pretty much instantaneous from 40 miles away.
Exactly. But the physical shockwave, the actual displaced air, that travels roughly at the speed of sound. So for a man sitting 40 miles away, the sky becomes an incandescent sun, and the thermal radiation hits him instantly.
Baking his skin and his clothes.
Yeah, literally baking him. And he is left in this agonizing silent terror for several minutes before the actual wall of pressurized air catches up and violently throws him to the ground.
Just sitting there on fire in the silence. But wait, if it didn't even hit the ground, how does it do that much damage? Because, when we think of a rock from space, we think of a meteorite, right? A massive crater in the Earth.
Right, like the ones you see in Arizona or on the moon.
Yeah, exactly.
Yeah.
But this happened in the sky.
Right. What Semenoff witnessed was an airburst. And to really understand an airburst, we have to look at the mechanics of atmospheric entry.
Okay.
We were likely looking at a stony object, essentially an asteroid, roughly 50 to 60 meters across.
So like the size of a large office building.
Yeah, a good-sized building, and it is moving at cosmic velocity, perhaps 30,000 miles per hour or even more, as it hits the Earth's upper atmosphere.
But, the atmosphere at that altitude is incredibly thin, isn't it? It's practically a vacuum up there.
It is thin, yeah, but velocity completely changes the rules of fluid dynamics. When you hit any fluid, even a very thin gas, at 30,000 miles per hour, it acts like a brick wall.
A brick wall of air.
Exactly. The rock is moving so fast that the air in front of it simply cannot get out of the way in time. So it compresses. This phenomenon is called ram pressure.
Ram pressure.
Right. And just like a bicycle pump gets hot, when you rapidly compress the air inside it, the violently compressed air in front of this asteroid superheats into a brilliant glowing plasma.
Wait, so it's not actually friction that causes a shooting star to burn up, it's compression.
Mostly compression, yes.
Yeah.
That's a common misconception. It's the ram pressure. And this plasma blanket is thousands of degrees. It begins melting the outer layer of the stony asteroid, literally peeling it away in a process called ablation.
Okay, so it's melting away.
It is, but the critical failure isn't actually the melting, it's the mechanical stress. The ram pressure pushing against the front of the rock is battling the rock's own internal tensile strength.
Like trying to crush a stone in a vise.
Precisely. And between 5 and 10 kilometers above the Siberian ground, so roughly 3 to 6 miles up, the pressure differential became intolerable. The 50-meter stone simply could not hold itself together anymore.
Oh, wow.
It fragmented, which instantly increased its surface area, and that caused all of its kinetic energy to convert into heat and pressure in a fraction of a second. It just detonated.
It detonated. It's like if you take an explosive and detonate it inside a tightly closed fist, right? The damage is concentrated right there in your hand.
Wow.
That's a ground impact. That's your crater. But if you detonate that same explosive in the open air, just a few inches above a table, the shock wave travels outward and downward, and it slams into the surface over a much wider area.
The open hand above the table spreads the devastation. That's a perfect analogy. Because there is no crater, the energy is not absorbed by displacing millions of tons of bedrock.
So it all goes into the air.
Yes. That downward shockwave becomes a giant hammer, just flattening the taiga underneath it. And the scale of the energy is staggering.
It really is. And I want to make sure we are totally honest with the numbers here, because the literature shows a bit of a range. The estimates for the explosive energy span anywhere from 3 to 50 megatons, depending on, the specific computer models used.
Yeah, the models can vary.
But the general scientific consensus lands right around 10 to 15 megatons. And to put that in perspective for you listening, that is roughly 1,000 times more powerful than the atomic bomb dropped on Hiroshima.
1,000 Hiroshimas detonating 3 miles above the Earth. Just think about that. First, the initial flash of the explosion scorched the forest below, igniting the canopy of the taiga instantly.
Just everything catching fire at once.
Instantly. And then seconds later, the physical shockwaves slammed down and flattened all those burning trees. The result was the leveling of approximately 2,150 square kilometers of forest.
Which is roughly 830 square miles.
Right. Now, we have to be precise with our language here. This is the area where treefall was definitively observed. Topography plays a role, hills shield certain valleys, that kind of thing. But the general footprint was this massive, radial, butterfly-shaped pattern of destruction.
A butterfly shape.
Yeah. And within that zone, An estimated 80 million trees were snapped like matchsticks.
80 million trees
Yeah.
in an area the size of a major metropolitan city, which actually brings us to something vitally important.
Yes, it does.
Because when we talk about Siberia, the standard historical narrative paints this picture of a vast, empty wilderness. But both of us need to emphasize a crucial correction from the source material. The taiga was not empty.
No, it was only empty from the perspective of the Russian bureaucrats in St. Petersburg. In reality, this region was the homeland of the Eventy people.
Right.
They are indigenous reindeer herders who had lived, hunted, and really thrived in this ecosystem for centuries. To describe the stage of this cosmic impact as an empty wilderness is a profound erasure of their existence and their suffering.
It really is. And the sources show how deeply this event shattered their world. And it wasn't just the physical loss, though that was obviously devastating. The human casualties were miraculously low, perhaps 2 or 3 direct deaths, but the shockwave obliterated their livelihood.
Completely obliterated it.
Thousands of reindeer were incinerated or crushed by falling timber. Their storehouses, their teepees, their entire immediate reality was flattened and burned in an instant.
And their cosmological understanding of the events is equally profound. In Evenki oral tradition, the blast was interpreted as a visitation by Ogdi, who is the god of fire and thunder.
Oh, wow.
Yeah, they believed Ogdi had cursed the area, which fundamentally altered how they interacted with that land for decades. They avoided the epicenter entirely, treating it as a sacred and highly dangerous zone.
Which is a completely rational response to your forest exploding.
Absolutely. And what adds insult to their profound injury is how their voices were treated in the aftermath. Because the Evenki were the true eyewitnesses, right? They experienced the heat, they navigated the scorched earth, they knew exactly where the trees had fallen.
But nobody listened to them.
No. When outside scientists finally arrived, they just sidelined the Evenki accounts. They talked over the very people who had survived the apocalypse because the locals' oral histories didn't match the Europeans' preconceived scientific models.
They just dismissed them, which perfectly sets up the next immense mystery of this deep dive. Because you have a blast 1,000 times more powerful than Hiroshima. You have 80 million trees knocked flat. You have a sky glowing over London, and yet nobody goes to look.
The world just turned the page.
It's crazy. It would be 19 years before anyone from the broader scientific community actually made it to the epicenter. The signal was completely lost.
It is a confluence of incredibly difficult geography and violently turbulent geopolitics.
Okay, let's break that down. Geography first.
Right. First, the geography. The site of the Tunguska event wasn't just rural, it was a trackless bog. There were no roads, there were no railways, there was no easy river access that could take a large scientific expedition safely into the epicenter.
Especially carrying heavy equipment.
Exactly. Navigating the taiga, especially in the summer when the permafrost melts and turns the ground into this treacherous marsh swarming with gnats and mosquitoes, it was just a logistical nightmare.
So just getting there was a borderline impossible task in itself. But it wasn't just the mud, right? The timing of 1908 places Russia on the precipice of total societal collapse.
Yeah, the timeline of Russia in the years immediately following the blast is pure chaos. You have a buildup to World War I, which fully breaks out in 1914. That war takes a catastrophic toll on the Russian population and economy.
Right, millions dead, the economy in ruins.
Which leads directly to the fall of the Tsar in 1917, then the Bolshevik Revolution, and then a brutal, drawn-out civil war that consumes the entire country into the early 1920s.
So they were a little busy.
It's a little. The entire society was fighting for its survival, fundamentally restructuring its political reality. The new government was certainly not going to fund an expedition into a swamp to look at some fallen trees.
But regional newspapers in Siberia actually ran the story in 1908, right? I saw that in the sources. They interviewed people. The information was out there. But the academies in St. Petersburg just barely noticed it.
They ignored it entirely.
Until a man named Leonid Kulik enters the picture.
Yes. Kulik is a fascinating figure. He was a mineralogist, basically a meteorite specialist at the Vernadsky Institute in St. Petersburg. Starting around 1921, as the Civil War is finally winding down and the Soviet state is beginning to establish its scientific bureaucracies, Kulik starts collecting these yellowed 13-year-old newspaper clippings.
Just digging through the archives.
Right. He begins gathering local accounts, finding these whispers of a fiery sky and a flattened forest, and he becomes obsessed. He knows, mathematically, that a blast of that size had to have left something behind.
But he still needs money. And he can't just walk up to the newly formed Soviet government and say, I want to go solve a cool mystery. They are intensely pragmatic. They're trying to rapidly industrialize.
Exactly. So Kulik makes them a promise. He leverages the scientific paradigm of the time, which was that a massive explosion from space must equal a massive hole in the ground and a colossal piece of space metal.
Makes sense.
So he sells the expedition to the Soviet authorities not as a scientific curiosity, but as a salvage operation. He promises them a mountain of usable, highly valuable meteoric iron.
That is just such a clever play. He knew exactly what they wanted to hear.
Oh, he knew perfectly.
And he gets his funding. And so in 1927, which is 19 years after the sky caught fire, Kulik finally mounts the expedition. And I was reading about this slog, and it is brutal. They are taking the Trans-Siberian Railway, then navigating the treacherous rapids of the Angara River, and then plunging into the taiga.
On foot and on horseback.
Yeah, and they are dealing with scurvy, malnutrition, and the Evidinki guides actually refusing to take them all the way into the cursed zone of Agdi.
Can you blame them? It was an exercise in extreme endurance. Kulik was carrying heavy surveying equipment, these delicate theodolites, large glass plate cameras, dragging all of this through melting permafrost.
That's miserable.
It was. And he is riding on this immense expectation. He's picturing a massive, deep crater, very similar to the Barringer crater in Arizona. He expects to look down into this bowl and see this fortune in iron just waiting to be hauled out.
And then he finally breaches the perimeter. He sees the edge of the tree fall, and he maps his way inward toward the epicenter. And what he actually finds is just surreal. He steps into a vast radial graveyard, millions of splintered trunks all pointing outward, away from a central point.
Like spokes on a wheel.
Yes,
Yeah.
exactly. And he follows this compass of dead wood all the way to the dead center of the blast.
The anticipation must have been unbearable for him. I mean, he reaches the very center, the exact mathematical epicenter of 1,000 Hiroshimas. And what does he find?
Nothing.
A marshy bog, no crater, absolutely no meteorite, no mountain of iron for the Soviets. Just a swamp.
Okay, but here's where it gets really interesting. Because at the dead center of this radial graveyard, surrounding this bog, are trees that are still standing upright.
Yes.
They are completely dead. They are stripped of every single branch and all their bark, but the trunks are pointing straight up into the sky. They called it the telegraph pole forest.
Oh.
But how is that even physically possible? If you are at the very center of an explosion that knocks over 80 million trees, how are the trees right underneath it still standing?
This is the genius of the physics at play here, and it was the exact physical proof of an airburst, though it took years for the scientific community to fully parse the fluid dynamics of it.
Yeah.
Think about the direction of the force.
Okay.
For the trees that were miles away from the epicenter, the shock wave from the explosion high above came at them from an angle. It hit them sideways, pushing them over, snapping them at the base.
Right, pushing them away from the center. Okay, imagine you have a sprig of rosemary in your hand. If you hold it upright and run your fingers straight down from the top to the bottom, you strip all the leaves and little branches off, but the main stem stays perfectly straight.
That is a brilliant way to visualize a Mach stem shockwave. The downward shockwave acts exactly like your fingers on that rosemary sprig. It shears off every branch, perfectly stripping the tree. But because the force is entirely vertical, pushing straight down into the earth, it essentially pins the main trunk into the ground.
It doesn't push it over laterally.
Exactly. It hammers it deeper in. Kulik was staring at the physical proof of an explosion in the sky.
You just have to feel for Kulik in that moment, though. 19 years of obsession, the brutal trek, the promise of iron, and he finds a swamp surrounded by naked trees. His expedition didn't resolve the mystery at all, did it? It deepened it. Because if there was no iron and no crater, what exactly fell from the sky that morning?
This raises an important question, one that remains a genuine, ongoing scientific debate even today. And it's crucial we emphasize to you, the listener, that we are not here to declare a definitive winner. The data simply doesn't allow for absolute certainty. But we can look at the two primary viable theories that attempt to explain the physics of the blast and the lack of a crater.
All right, let's lay out the camps. On one side, you have the mainstream scientific consensus, which heavily favors the asteroid theory.
Yes. Mainstream science points to a stony asteroid. Unlike a metallic asteroid, which is dense and more likely to survive atmospheric entry to create a crater, a stony asteroid is fragile.
It breaks apart easier.
Right. As we discussed with ram pressure, a 50-meter stony asteroid would experience catastrophic mechanical failure. It detonates high in the air, creating the exact blast pattern Kulik found. And the lack of large fragments makes sense, because the extreme heat of the airburst would vaporize the stone, turning it into dust that just dispersed in the wind.
And scientists have actually found evidence of this vaporized stone, haven't they?
Yeah.
I read about the expeditions in the 1950s and 60s where they took core samples from the peat bogs at the epicenter.
They did. Decades after Kulik, researchers analyzed the layers of peat that corresponded to the year 1908. They found microscopic spherules.
What are spherules?
They are tiny, glass-like beads of melted rock, specifically containing magnetite and silicate. They also analyzed the chemical composition of the resin trapped in the surviving trees, finding isotopic signatures that strongly point to an extraterrestrial stony body.
So the asteroid theory neatly explains the blast physics and the microspherules. It explains the destruction on the ground. But then we have the other camp, the comet theory. And this theory pulls us all the way back to the very beginning of our deep dives, back to the woman reading in the garden in London.
The comet camp points to those bright nights in Europe and says, well, a stony asteroid doesn't fully explain the silver rose glow, but a comet does. A comet is fundamentally different from an asteroid. It is essentially a dirty snowball. It is composed largely of ice, frozen gases, and dust. If a comet entered the atmosphere and vaporized, it wouldn't just turn to stone dust. It would release a massive amount of water vapor high into the upper atmosphere.
And that water vapor would freeze into high-altitude ice clouds. But how does ice glow at night? I've never fully understood that mechanism.
It has to do with the geometry of the Earth and the atmosphere. We are talking about noctilucent clouds, which form in the mesosphere roughly 50 miles above the Earth's surface.
Okay, 50 miles up.
Because the Earth is curved, the sun can set for you standing on the ground, plunging your garden in London into darkness. But 50 miles straight up, the sun is still shining over the curve of the horizon.
Oh, wow. So the clouds are so high up, they're literally still in daylight even at midnight.
Precisely. The vaporization of a comet over Siberia would have seeded the mesosphere with microscopic ice crystals. High-altitude winds caught these clouds, spreading them westward over Europe. They sat 50 miles up, catching the sunlight from over the horizon and reflecting it straight down to the surface, creating that magical, shadowless glow.
If we connect this to the bigger picture, isn't there a huge contradiction here? This is what I find so maddening about this mystery. If a stony asteroid explains the blast physics best, because it has the density to punch deep into the atmosphere before detonating, how do we explain the glowing London sky? But conversely, if a comet explains the glowing sky perfectly, does a loosely packed snowball actually carry enough kinetic punch to penetrate down to 5 kilometers and flatten 80 million trees? Wouldn't a comet just burn up harmlessly way higher up in the atmosphere?
That is the exact tension that keeps the debate alive. Asteroid models have to stretch to explain the widespread atmospheric glow, perhaps citing dust reflection rather than ice, though dust doesn't reflect light quite as beautifully as ice crystals. Comet models have to stretch to explain the penetration depth, usually proposing a comet with an unusually dense, stony core that could survive the plunge. It is the hallmark of a really healthy scientific mystery.
And because human nature utterly abhors a vacuum of information, this tension has led to alternative theories. Some are grounded in real science but heavily debated, and some are just wildly fringe. Let's talk about the false leads, specifically the Lake Chicot hypothesis. Because between 1999 and 2007, an Italian research team from the University of Bologna proposed that a small lake about 8 kilometers from the epicenter was actually a small impact crater. They theorized a chunk of the main body survived the airburst.
It was a highly publicized theory, but within the broader scientific community today, it is widely doubted. It is a classic false lead.
But wait, the Bologna team's data seems really compelling. I looked at their seismic reflection profiles. They found a distinct conical shape to the lake bed, which is unusual for natural lakes in that region. And their instruments pointed to a dense, stony object buried about 10 meters below the lake floor. That's physical evidence, isn't it? Why did the broader community throw that out?
It is compelling data until you test it against biological and geological realities. The conical shape is unusual, but not impossible for a thermokarst lake, which is a lake formed by melting permafrost. The definitive rebuttal came in 2017.
What happened in 2017?
Russian researchers went back to Lake Chicot and took deep core samples from the lake bed. They performed rigorous radiocarbon dating on the sediment layers. Their results showed that the deepest sediments in the lake are over 280 years old.
So the lake predates the 1908 event by over a century.
Exactly. A lake cannot be a crater from 1908 if it existed in 1708. It was a tantalizing lead, but rigorous scrutiny of the physical timeline ruled it out completely.
And then we get to the fringe theories. Because when you have an explosion of 1,000 Hiroshimas with no obvious culprit, people are going to start filling in the blanks. We're talking theories about a chunk of antimatter hitting the Earth, or a microscopic primordial black hole passing straight through the planet. My personal favorite, Nikola Tesla accidentally firing a Jeth ray from his Wardenclyffe Tower in New York all the way to Siberia. And, inevitably, an alien spacecraft suffering a warp core breach in the atmosphere.
When conventional explanations leave a sliver of doubt, the imagination just rushes in. We name these theories only to explicitly set them aside. They are entirely unsupported by any physical evidence, physics, or basic planetary science. The reality of a cosmic impact is terrifying enough. It doesn't require alien spacecraft or death rays.
Which brings us to today. Because we are not just telling a spooky historical story about a flattened forest. The reason you should care about Tunguska right now is because it is profoundly relevant to our survival. Tunguska is the modern benchmark for the near-Earth object hazard. In fact, June 30, the anniversary of the sky-catching fire, is officially recognized by the United Nations as International Asteroid Day.
And that designation is a vital call to attention. Tunguska represents the exact threshold of our vulnerability. The objects that wipe out dinosaurs, the multi-kilometer planet killers, those are rare. And because they are so massive, our telescopes can track almost all of them decades or centuries in advance.
You see them coming.
Yes. But an object 50 to 60 meters across, the size of an office building, there are millions of them in our solar system. They are small, they are dark, and they can come at us out of the glare of the sun with absolutely zero warning.
And this is why we have modern space missions, like DART, the Double Asteroid Redirection Test, where NASA literally crashed a probe into an asteroid to see if we could alter its kinetic course. It's why we are building the INEO Surveyor Space Telescope, specifically designed in the infrared spectrum to hunt for these dark, city-killing rocks. These missions exist precisely because of what happened in 1908. We are finally, a century later, trying to build a defense against the very thing that flattened the taiga.
The scientific community looks at Tunguska and realizes we dodged a cosmic bullet purely by the grace of geography.
So what does this all mean for you? As you sit there listening to this, what is the takeaway? It's the sheer, chilling ordinariness of the event. I want you to really think about the timing. This rock arrived on a routine summer morning. The Earth was just spinning on its axis, going about its business. If that object had arrived just 4 or 5 hours later, the rotation of the Earth would have placed a major metropolitan area, perhaps St. Petersburg, perhaps a European capital, directly under the crosshairs. If that airburst happens over a city, you don't get a telegraph pole forest. You get pulverized concrete and glass. The dead wouldn't have been numbered in the 2s or 3s. They would have been numbered in the millions.
It would have fundamentally altered the trajectory of human civilization. The 20th century would have been defined not just by world wars, but by a cosmic catastrophe. A piece of the Earth the size of a great city was rearranged in a fraction of a second, and the rest of the planet noticed only that the nights had turned briefly, beautifully bright. It's a profound testament to our fragility.
It really is. And I want to leave you with one final thought to mull over, something that builds on everything we've just unpacked from these sources. We know that the Tunguska event happened just over a century ago, and we know that our only global warning, our only widespread symptom, was a beautiful glow in the night sky. Considering that 70% of the Earth's surface is covered by open oceans, if an impact of this exact size happened 200 years ago or 500 years ago over the middle of the Pacific, would we even know? How many Tunguskas have happened throughout human history, entirely unnoticed by us, sinking into the waves without a trace? We spend so much time staring up, looking for the massive, planet-killing asteroids. But perhaps the true cosmic ghosts aren't the giants we can see coming. Perhaps the true ghosts are the small, silent ones, the ones that slip past our defenses on a summer morning, deliver a blow of 1,000 Hiroshimas, and leave no crater behind.